The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. My name is Catherine Batista with the Alliance, and I'd like to welcome you all to our February practice sharing session. Before we get started, I'm just going to read the Alliance's antitrust statement. So we want to advise all participants that these meetings and all activities related to the Electric Utility Industry Sustainable Supply Chain Alliance are subject to compliance with all federal and state antitrust laws. We will not discuss any company-specific pricing, vendor terms and conditions, discounts, or anything else that may affect prices, allocation of markets, specific vendor experiences, or any other competitively sensitive information. So before we get started today, I just want to remind everyone that you're all muted. So if you have any questions, please just type them into the chat box in that little GoToWebinar window, and I will make sure that they get to the presenters. So let me introduce our speakers today. We're actually going to be hearing from one of our own members from Southern California Edison. So we have Erwin Wen and Mustafa Ali on the line, and they're going to be telling us about their AMJACK system and how it provided an alternative to replacing existing towers for conductor clearance violations. So whenever you're ready, guys.
All right. Good morning or good afternoon, wherever you are. My name is Mustafa Ali. I'm the Transmission Engineering Manager for Southern Cal Edison. Today I'm going to walk you through some of the innovative solution that we discovered and we implement an Edison system. So with that said, the briefing is going to touch on the following, why basically the reason behind utilizing this technology, which we call it AMJACK. Then what creative solution we came up with, the journey of innovation, and then key takeaway. We're gonna display some videos and photos if time's allowed. With that said, transmission line rating remediation, which we call it TLR program here at Edison. It was established back in 2007 when we discovered that some of our bulk systems have issue of discrepancy to code. We realized that might have a significant impact on our operation. So in 2007, SCE decided to conduct comprehensive survey using LiDAR system to the bulk system, which most of utilities are familiar with. And along with those bulk system, we included some of the key CAL-ISO, which is California Independent System Operation lines, to be included as part of that system, which includes some 55 kV, 115 kV, 66 kV. So we LiDAR the entire system of those particular line, and we collectively discovered that there was a significant number of discrepancies. We call it discrepancies, not infraction, immediately, because we needed to conduct a field study on it. So we did that. We completed the study back in 2010. After 2010, we realized that collectively, after we did field investigation, there was approximately over 11,000 infractions that need to be mitigated. We timeline this with FERC requirement to be completed by 2025 for the bulk system and 2030 for the sub-transmission. And part of this journey through this challenging mitigation that we have to come up with, we come across this technology that we felt improved in our ability to mitigate in a timely fashion. So traditionally, what it means, infraction in the sense of it's when the conductor heat, it sag and cause clearance issues. So the only way for you to mitigate that is to raise that wire up to meet either NESC code or in California, which is more strict code called GO95. After we did those studies, so now the mitigation plan would be, okay, we need to raise those structures or raise that conductor. And the only point for you to raise the conductor is to raise the tower or the structure that's lifting those conductors. So traditionally, if the typical method of mitigation raising structure is either you grade the ground, so you make it lower, and that's where you gain the clearance that you require. But that mitigation would impact significantly the disturbance. It needs significant time for permitting. It might have significant impact environmentally as well, because the disturbance could take a significant amount of dirt to be moved, removed, compacted, relocated if there's contamination. The second aspect would be replaced with a new, taller structure, and at that point, again, it's a cost, because now you need to build a new foundation, remove a lot of dirt. You have to impact right away, because sometimes your right away is limited, permitting, and outage constraint as well. Another aspect you can use is interset a new structure. Again, similar to the above one, which replacement, it will cost you, permit, disturbance, and other minimum aspect we can use is decrease conductor sag. And how we do that, there's two ways of doing that. Either you can retension the line, but there's so much you can retention in the conductor without impacting the structure integrity and the line integrity. Or the other aspect is derate the line, which was not possible for us in SCE system because the demand is still there. Next. So we discovered that AMJACK would be a very good candidate. So when I'm going to explain what does AMJACK mean. AMJACK, basically you raise the structure that you have in an existing system. You develop a kit that allow you to raise those structure without basically having to lift the entire body. The wire will be intact. If there's some people familiar with the old system, you used to use what they call a gym pole type of things, but this is more now due to advancing technology. It's all automated. AMJACK, basically, it's a company that provided that service. And I'm calling it here on this presentation, as you see, a small e ET, which is engineering, procurement, and construction. Because there's a huge upfront engineering activity that have to take place to mitigate those infractions, and not only that, to determine the existing structure integrity, the ability for the structure to add that height, the ability for that structure to handle that raising without creating any disrupt to the system. So there's a lot of background that have to take place. So we say E because Edison are very involved in that part. We do a lot of upfront engineering prior to us asking AMJACK to give us the procurement and construction pieces of it. So AMJACK technology benefits over the conventional tower raising method is we can increase the transmission capacity. I know the conventional way can do that, but the main factor here that we see is the advantage is the lower cost, because we realized a saving of over between 25 here, and I'm stating between 25 and 75% cost saving. However, through our experience, we have realized of about 50% saving in a lot of the cases. It reduced the construction duration. What does that mean? Besides the saving in cost, is reduce safety risk, because you don't have a lot of construction crew out there working for several days, several weeks, because typically, if you're gonna build conventional way, it takes you about at minimum, if you have outage, about 2 weeks to raise a structure. If you're going to interset and put a new foundation, it would take about a month because you need to put the foundation first and let the concrete cure, and then you start building your structure. It is extremely low on environmental impact because there is zero, to insignificant environmental impact because there's no dirt is moving. There's minimum equipment needed on ground, minimum number of crews that need to implement that AMJACking, light trucks, and actually some of this equipment that allow you to raise the structure on the spot can be flown through via helicopter because to the limited accessibility to certain line. The biggest advantage that we start earning here is we can work on those line hot, meaning the line energized. It was a quite significant impact on our schedule because especially in working on the bulk system, we had significant schedule delay that caused us to cascade the impact to several years. But with having the AMJACK handy here, we were able to conduct a lot of construction. On the next slide, I might be presenting how many structures we were able. So at SCE, last year in 2017, we were able to install over 80 AMJACK system, meaning we raised 80 structures. When we look at the schedule in comparison to what's going to be conventional, it was going to take us maybe about 5 structures a year to complete, which means because due to the outage constraint, comparing to 80 structures that we completed, and with a saving of over $35 million. That was quite significant, and we have on board typically an environmental crew that kind of monitor this stuff. For the initial couple of installation, when they looked at it, they said we don't need to monitor that anymore because it's have no significant impact at all. So our anticipated plan is for 2018 through 2019, approximately an additional 200 structures that we're going to be able to utilize AMJACK system. Let me caveat that AMJACK is not typically the ultimate solution, or that's the only solution, and in some cases it might not be the solution. But for our purpose here to mitigate a lot of different fractions, AMJACK came up very handy. Now, as a matter of fact, we're mixing AMJACK with some reconductoring aspect as well too, because as you can see, when you look at the line holistically to mitigate the infraction, it could be a combination of multiple options. So we start merging AMJACK with reconductoring using some of the high temperature, low sag conductor, which is using composite core conductor, which is lighter. So we were able to capitalize in using existing SCE tower. Some of it was built back in 1930. Some of it is 1907, but the steel was in a very good condition. So we were able to utilize AMJACK system along with reconductoring using light core conductor, which the structure can handle, and push more ampacity through the line. On the next slide, I think we're going to display some of the video that we made around AMJACK.
It's very important for engineering to be creative and innovative in our industry related to the electrical grid and electrical system, because there is a huge change in the industry from the issue of demands, limited resources, limited right-of-way. So coming up with a creative idea to capitalize on existing system, increase the capacity without the need to purchase new right-of-ways, change the structure totally, that brings a lot of value to the customer. We are doing it with the less cost
we provide the solution of actually giving the utility the ability to raise the towers, keep the line on, and gain extra capacity out of the line. The tower's actually never separated physically because it's always held by AMJACK. We call it having positive control, right? So we have positive control on this tower, which really allows us a lot of increased safety because you're not working underneath a suspended load anymore, right? So the tower is being held by AMJACK at all times. We have independent control on all of the cylinders, so there's no more pounding and beating bolts out. If we need to go up 1/8 of an inch, we just go up 1/8 of an inch. We can select one ram or all four at any given time. So it makes the process of installing the steel a lot safer, more efficient. It takes wear and tear off on tools and the guys doing it.
This type of construction method is really a game changer for our transmission system because it allows us to achieve our objective with a very streamlined process. It reduces the amount of environmental impact. The fact that we can raise this tower with this new technology, it reduces the environmental impact. It eliminates a lot of the licensing effort that we need to go through. And by doing so, allow us to achieve our objective. And it's really just overall a great technology, a great construction method that we can deploy to the rest of our system.
The benefits of raising structures energized is that it allows Southern California Edison to be able to do several things. We don't have to take an outage on the line. So not taking an outage on the line allows us to be able to schedule all of these structure raises without having to take that into account, which sometimes did prove to be difficult based on load on the system and on the grid. So that's one of the benefits of raising structures energized. We are also able to do multiple structures. It's really great that we can, go through 4 or 5 structures and get these done without having to impact the Edison system.
Edison's core mission is really about bringing electricity to our customer in a safe, reliable fashion. And this type of construction method increases the reliability of the system and allow us to continue to provide safe and reliable and clean energy to our customers.
So that's kind of a brief video that we made just to show the case of how that technology can be implemented. So in general, we're going to talk about some few photo sequence. But before I say that, just a caveat, and maybe that's the engineering part of me that get me excited about it. We raised the first 500 kV. That was going to be monumental, never happened before, and the line energized. The reason why 500 kV, because the voltage is significant, so the risk factor is significant. The size of the structure is huge. You're talking about lifting almost about 40,000 pounds above you. That is significant that the machine was able to, those 4 pistons was able to handle that. The technology behind that is that piston used, it's not using any bolts. It's just based on friction base that's lifting that structure. So it's amazing how that came up to play and became material science in action. So we were thrilled with that. And the second monumental part is we lifted 20 foot of structure, which didn't happen before, in 3 days, which is typically, it takes longer. Besides longer, the company never raised more than 15 foot. That was the maximum that they raised, but we were able to, through some technical bracing of the structure, to handle that factor. This is for some caveat for the technical people there, if there is any. But the saving was significant, and the safety factor that we did not have no incident at all over the 80 structure that was installed. That was got the thumbs up from environmental. That we saved ratepayers significantly compared to do it in a conventional manner. That was some substantial gain out of this technology. So this is typically the sequence of construction tower. So day one, we bring all the piston and equipment to the site, and then you start installing those pistons on the four corners of the structure. The same day, what we do is we develop a kit that allow you to prep, basically, to make sure in case of significant wind, you still have to secure the structure. So we have what we call it adapter plates already in place, and then the next day we start the separation of the tower. So you cut the pieces and you start lifting automatically, and then what we try to do to control it, we do 5 foot a day typically. And then the next day we secure it. Before the crew leave for the day, they secure it using those adapter plates to make sure, even though the piston can handle the weight, can sustain any changes, but of course, from safety perspective, we determined that we need to put those secure adapter plates in place, and then the hydraulic lift to start. And as I stated, 5 foot increment a day. Some certain days we were able to do 10 foot, especially in the case of that 20 foot raise that we did. And you keep going. The next day you add the section of steel that you need. You add the 5 foot. You come to the next section. You raise it. You add the second 5 foot. Once the structure is complete, we typically go check on everything, make all the members are fastened and bolts are really tightened, and check on the structure, and we're done in 3 days basically. Some key limitation is from safety perspective, we typically try to avoid any work for a wind greater than 25 miles per hour. And we have a kind of like a little weather station there that we kind of monitor the system. We typically plan for it as well ahead of time. In a couple of weeks, typically we kind of review and check the weather condition in the area that we are working on. Another challenge is from environmental, which is very minimal, which is nesting bird. And that might be a showstopper sometimes. Actually, on our second installation, that's what happened. On a 500 kV, we realized there was a nesting bird. What we did is we had crew mobilized already and scheduled. Luckily, the structure adjacent to it was identical to the same structure that we needed to lift, about 15 foot. We ended up kind of shifting the equipment about 1,000 feet away from the other structure, and we did the same installation with no disturbance to any bird. That's all what I have, and I think we'll open that discussion to QA, question and answer.
Great, thanks Mustafa. I just want to remind everyone that you're muted, so if you have any questions, just type them into the chat window there. But while we wait for some questions to come in, I just had one. How much time does it typically take to raise a structure if you aren't using the AMJACK system? So I guess just how many hours do you estimate that you saved in the power outage time this year?
Excellent question. Typically, let's say I'm going to raise the same structure type. Initially, what you do is you can't use the same location. So you're going to move the structure, what they call it, half footprint, because most of our structure is like batter's angle, so the foundation is not going to line up with the current existing foundation you have. So what you do is you build adjacent half a footprint foundation. For the foundation to take place, a cure about 28 days. From there, to put the steels and added structure, it take about a week to two. So you're talking a couple of months. And then with the complication of taking the outage, that's another aspect to it too. There's some of the structure you can add what they call vertical raising. It's possible, so you can use the same foundation, the same, and that's very limited application to it sometimes. On those one, typically, let's say at minimum, it will take you about a couple of weeks, plus the outage complication.
Yeah, that's amazing. So significant time savings there. So one question that has come in was, did you have any regulatory agency that you needed to approve this practice by prior to its implementation?
We did. We have a Edison, what we call it, the GO 131D committee that we won, and we presented to them what we're doing. The main concern was from environmental impact. So when they get the thumbs up from environmental, it was no issues. And actually, as a matter of fact, we adapted that system to be as part of typical O&M level work. So no permitting needed every time we need to install this system.
Great. So we'll just try to get a couple more questions in before close at 2:30. But it would be great to hear more about the waste that you guys avoided during this implementation. So how much material would be used for a standard replacement or upgrade?
I'm going to talk in sense of pounds. So for example, typical 500 kV raising structure, you're talking about 10 to 15,000 pounds if we're going to do a conventional way. Here you're talking about close to 700-800 pounds of steel that we typically use. Some of it, if it's, let's say, the maximum 15 foot or 20 foot, you're talking about maybe not to exceed 1,200 pounds.
One other thing, we've been able to quantify the cost of, or the impact with less trucks and, I mean, that's construction waste. I imagine that's a trickle down, right? Because you don't have all that heavy equipment. You don't need, the type of cranes and everything from that would be required to set the foundations and all that construction material that would be left over and then have to be disposed of. I mentioned that's pretty significant.
Absolutely. We did not capture that. I'm just talking
Steel weight.
Steel weight,
Yeah.
Construction time frame, and all these. So if we add this, it will be substantial. Plus the time it takes you to get the permitting. All this stuff, and the different agents involved to get you those permitting, it's another added cost.
And then one more question for you guys. Does this have any impact to any potential warranties from the original tower manufacturer?
Excellent questions. Typically, those structures that we have in Edison systems been over 100, so there is no warranty on them already. So we are responsible about completely. However, part of our agreement with this company to give us a warranty of minimum 24 months, which is 2 years. If any things happen due to failure of pieces that they install, then they are fully responsible about it. Up to $1 million, I believe.
Great. Thanks, guys. So I'm just going to stop the questions there. I want to just thank everyone for joining today. And if you have any more questions, you can reach out to me and I can provide you with the contact information for Mustafa and Erwin. But I just want to thank you both for presenting. And I just want to remind everyone on the call that our next practice sharing webinar will be held on March 20th. And we're going to be hearing from a supplier called Call, and they are a distributor of PPE and disposable biodegradable gloves. So they're just going to be talking about their cost neutral alternative there and how their glove decomposes in 5 years or less compared to a regular disposable nitrile glove, which takes 100 years or more. So please make sure that you check the Alliance website for more information on signing up for that. But that's it for today. All members are now invited to dial into the member call, and we'll continue our conversation over there. Thanks, everyone.
Thank you.
Thank you.